out there, algebra people. Today I'm going to give you a quick overview of one of the units that we did not get to in the spring, but it's super easy because Desmos will do almost all of it for you. So if you'd like to know some things that we missed and maybe information that you would like to take into geometry with you, and you don't feel like doing a ton of work, this is your unit because it's pretty simple. This is inequalities, and you have some experience with inequalities already from last year, but specifically we are going to talk about linear inequalities, which we are going to graph instead of on a number line, we'll be graphing on a coordinate plane. Let's do a quick review of inequalities, all right? If I have an equation, if I solve this equation by dividing by 3, I get one answer. X is equal to 3, and that's it. X cannot be anything else. It can't be 3.1, it can't be 2.9, it can't be negative pi. It can only be 3. If I were going to show this on a number line, I would just go to 3 and put a dot. Like, there's my answer. Okay. Remember that when we had inequalities, you're going to have either greater than, less than, greater than or equal to, less than or equal to. The solving is the same, but this time my answer is not just 3. X could be lots of things, and actually X can't be 3 because the symbol says that X is greater than 3. So anything larger than 3 could be the answer. 3.1, 3.2, pi, 9, 10, 1 million. I mean, there are literally infinite numbers that X could be. And remember that to show those on the number line, you would put an open circle for greater than or less than, and you would color to the direction of where all the greater numbers are, because it says X is greater than 3. So remember, we would color in this direction. Hopefully you sort of remember this from last year. If we had a different symbol, if we had greater than or equal to, that would mean we would color in the dot. That indicates that 3 is also a solution. Okay, hopefully you are remembering that. What we want to do now is talk about linear equations and linear inequalities. If we go back to a linear equation, if I say 2x equals 4y, I need to know numbers that x and y could be. Well, x could be 10 and y could be 5. So 10 comma 5 could be a solution, right? Let's think of something else. How about x could be 4 and y could be 2, because that's a true statement. So or 2 comma 2 rather. Let's see, would be like this. If we found all of the numbers that x and y could be, we would end up with a straight line. Remember that all the points on the line, all the x and y coordinates on the line are solutions to this equation. And what we're used to doing is we're used to taking this and solving it for y so that we have a y equals mx plus b kind of situation, right? But remember that at the end of the day, all of the points on the line will satisfy the original equation. If you plugged in x and y, they would end up equal to each other. Well, it's a little bit different when we talk about inequalities. Whoops, that's not what I wanted to do. Here we go. Let's say I have, instead of, let me give you 2. Let's go back to this one. Y equals 2x plus 1. My y-intercept would be 1. And my slope would be up to over 1, up to over 1. So my line would look like this, right? I'm going to show you what happens when we change the equal sign to an inequality. And we could have 4 different inequalities. and the graph is going to change each time. In order to make this easy, I'm going to switch over to Desmos. So let me pop over to Desmos. Let's put our original equation in. Y equals 2x plus 1. And I'm going to zoom in because I don't want my numbers to be so big. Here we go. Okay. So remember that all of the points that are on the line satisfy the equation. So just for grins, I'm going to say, okay, so here's a point 0, 1. If I put 1 in for y and 0 in for x, my equation is true. If I choose this point right here, which is 2, 5, if I put 5 in for y and 2 in for x, my equation is true. That's going to be true for every single point on this line, okay? Now, here comes the magic-y good part. Let me erase all this to leave ourselves some room. What if I change the equal sign into an inequality instead? I'm going to, let me close out this. Let's change the equal sign to a less than sign. Whoa, take a look. Look at what happened here. The line is in the same place, but two things happened. One, it turned into a dotted line. And two, half of the graph is shaded. Do you remember? Let me go back to the markup. Remember how we said if you were graphing an inequality that said like x is less than 2, you would use an open circle? Okay, so 2 itself is not an answer. That's what this dotted line represents, okay? What the dotted line represents is this is sort of like the open circle. So any point on this line will not work in the equation. The shaded area represents everything that would be shaded on your number line. Any point in this area will work for the inequality. And I'll show you that right here. So let's take a look at, first of all, a point on the line, like we had 0, 1. So if I put 1 in for y and 0 in for x, I get 1 is less than 1. That is not true. 1 is not less than 1. So that point does not work. If we take another point, I might need to zoom in a little bit to see. Let me find one that's actually on the line, and that is integers. How about right here? -1, -1. Okay. Let's say that I put -1 in for y and -1 in for x. Well, -1 is not less than -1, so that point doesn't work either. So all of the points actually on the dotted line will not work, but any point in the shaded area will. That's what we call the solution set, okay? The solution set is in the shaded area. So let's pick a couple of points in the shaded area and just try them out so that you can see. How about, and I've drawn so much on here, how about right here, 5, 0. If I put 5 in for y and 0 in for x, oh, I'm sorry, I have that backwards. Oops. 0 is y. I was going to say, hold on, this isn't working. 0 is y. 5 is x. There we go. Is 0 less than 11? Yes, it is. This point works. How about this one right here? 2, -3. If I put -3 in for y, 2 in for x, is -3 less than 5? Yes, it is. This point works. Any point in the shaded area would be considered a solution, okay? Now, I want to show you one other thing. Well, actually, two other things. Let's real quick change the less than into a greater than. Take a moment in your head, and I want you to predict what you think is going to happen. If we change the less than into a greater than. All right. Hopefully you predicted exactly what happened. The line, the dotted line, is in the exact same place, but now the shading is on the other side, okay? This is when we talk about greater than or less than, when we're talking about a coordinate plane. Anything, oops, that's not what I wanted to do. Markup, that's what I want. If you look at the y-axis, okay, anything, if you're shaded above the y-axis, that's greater than or equal to. If you're shaded below wherever the point is, wherever the y-intercept is, if you're below that, that's going to be less than or equal to. And you see that our equation now says greater than, and that's why the upward part is shaded. All right, let's look and see what happens if we change it from greater than to greater than or equal to. Maybe you have an idea in your head already of what's going to happen there. Let me back up and take a look now at the graph. What has happened is our dotted line has turned into a solid line, okay? So what we have is on our old graph, I need the, oh my goodness, why won't it mark up? Oh, there we go, I have to hit the markup thing. On our old graph, when we had greater than or equal to on our number line and we used a solid dot, that was the greater than or equal to, right? Well, on the graph, on the coordinate plane, the solid line is the same thing as a solid dot, okay? So solid line is the same thing as a solid dot. Dashed line is the same thing as an open dot. So again, just like with this one, any coordinates up in the solution area would satisfy this equation, or inequality rather. So let's take a look. Here is a point right here. -5, +5. So I'm going to put +5 in for y, -5 in for x, and I get 5 is greater than equal to -9. And that's true. 5 is larger than -9, okay? Any coordinates up in the solution set will work. That's how inequalities work, okay? I'm going to give you a practice page to do. It has graphs on it for you to draw the inequalities. You can certainly do that if you want to. But honestly, we have Desmos, let's just use it. So all you need to do is open up Desmos, graph the inequality that they give you, and then identify whether or not a given point is in the solution set. When you're done with that, check your answers, and then come back here to the video and pick up right here where we left off. We're going to talk about systems of inequalities. Okay, when we talk about systems of inequalities, just like systems of equations, it just means two inequalities instead of two equations. Remember when we had systems of equations, we had three possible solutions, right? If the lines crossed in one place, this was the only solution. That meant that particular x and that particular y were the only numbers that would work for both equations. We also had no solutions. That means there was no x and no y that would work for both of them. Or we had infinite solutions where the lines were right on top of each other and every x and every y would be part of the solution set. When we talk about systems of inequalities, it's a little bit more interesting because we have that shading on the graph to worry about. Let's say that I have, actually, let me go over to Desmos and show you what I mean because it'll be easier there. Let's say that I have y is greater than x plus 5. Okay, so here's my inequality. Now, let me give you another inequality. Let's say that y is less than x plus 8. Okay, so you see that, let me get my markup tool here and hopefully I'll do it right this time. With y is greater than, y is greater than x plus 5, that was everything up above here. Y is less than x plus 8 is everything below here. This band in the middle of overlap, these are the points that will work for both inequalities. And let me just illustrate for that for you very quickly, all right? Let's look at our first one. If I take this point right here, which is 2, 4. All right. If y is 4 and x is 2, then 2 plus 5 is 7. So see, that's not true. All right, because remember the first one was the red, and that's going up. So you can see that this point in the blue area is no good for the red equation or inequality. If I put the point here, 2 plus 8 is 10. 4 is indeed less than 10. So it does work for this inequality, okay? So any point that's out here or out here will work in one, but not both. If I pick a point in the shaded area, and I'm going to go for right here, which looks like 0, 6. If let's use 0 and 6. Come on, eraser. If I put 6 in for y, and if I put 0 in for x, this would be 5 and this would be 8. And you see that both of them are true. 6 is greater than 5 and 6 is also less than 8. So any point in the shaded area works. All right. Let me give you a different version of the inequalities. Let's do one with a positive slope and one with a negative slope. Let's say this. Let's say y, we're going to keep the first one, y is greater than x plus 5, and let's say that y is less than negative x. Yeah, let's just say negative x, okay? So what we have here is we have, I wonder if I can change colors. Okay, everything above, oh lordy, there we go. Everything above here works for the red. Okay. Everything below works for the green. And where do they cross? Right here. So this, the area that is shaded, and it's not just that part actually. If we make the graph, oh, I'm on a PDF and I can't do that. Hold on a second. If I change the size of the graph and zoom out some, all right, you see that shaded part gets bigger and bigger and bigger and bigger. You see the numbers getting huge, right? So anything in that shaded part will be a solution for both inequalities, all right? This is useful when we're doing word problems, and I know that's like your least favorite thing ever, but Desmos makes this so ridiculously easy. I'm going to pull up some word problems. Nope, that's not what I want. This is what I want. All right, and I'm going to have this sheet for you to look at, but I'm going to do the first two for you, and then you can sort of check yourself as you go. Remember that when we have word problems, the main trick is in just writing the problem correctly. Once you have it written, Desmos will do the graph and it'll be really easy to see the solutions. You don't have to do any math for that. This really doesn't require any math. It just requires you be able to write the equation. So take a look here. It says, suppose you buy flour and cornmeal in bulk to make flour tortillas and corn tortillas. Flour costs $1.50 per pound and cornmeal costs $2.50 per pound. You want to spend less than $25 on flour and cornmeal, but you need at least 6 pounds altogether. So remember, when we have a system, what we need to do is identify what our X and Y are going to be. So I am going to zoom in right here, and I'm going to say that X is going to be flour and Y is going to be cornmeal. Okay. Now, I know that flour costs $1.50 per pound, so it's going to be 150x, or 1.5. Cornmeal costs $2.50 per pound, so that's going to be 2.5y. Now, those two together, if I buy them both, it says that I want to spend less than $25. So there's my first inequality, easy peasy. The second statement says I need at least 6 pounds altogether. That means if I add my flour and my cornmeal together, not talking about prices, just talking about amounts, I need at least 6 pounds. So would that be greater than or less than? Well, ask yourself, would I be happy with 7 pounds, 8 pounds, 9 pounds, 10 pounds? Yes, because at least means 6 pounds or greater. So greater than or equal to 6, okay? Now what I'm going to do, now that I have that, is, that's not what I wanted to do. Sorry about that, guys. I'm learning how to use this iPad to drag things. There we go. All right. So now I'm going to, let's see if I can figure out how to make this. No, that's not what I wanted either. I had it just a minute ago. I'm trying to figure out how to do this so that I can make it half the screen. There we go, like that. Okay, now I've got it. All right, now that I have my equations, all I have to do is graph them and see what's on the graph. So I'm going to type in 1.5x plus 2.5y is less than 25. There's my first inequality, okay? Leave that one on the screen and then type the second one. X plus y is greater than or equal to 6. Now, my numbers are ginormous. Let's zoom in to the intersection point so we can see like actual numbers, all right? And what I really want to be looking at is where I want to be looking at the part of the shaded area that's between the x and the y axis, so like between 10 and 10, okay? When it says 2 possible solutions, I can't have negative amounts of flour or negative amounts of cornmeal, so I need positive number. If I take a look at, let's put black on here. I think that will be easier to see, okay? If I did like, since this is from 0 to 10, this must go by 2s. 2, 4, 6, 8, 2, 4, 6, 8. So I could order right here. Here's a point that's in the shaded area. 8, 2. Here's another point that's in the shaded area. 2, 6. All right. Here's another point that's in the shaded area. 4, 4. All right. Now, when they ask you for 2 possible solutions, they're not asking you to tell them the the point. They're asking you, well, what about the flour? What about the cornmeal? So if 8, 2 is one solution, what that really means is 8 pounds of flour and 2 pounds of cornmeal. Okay. One of the other solutions was what? 4, 4. So that means we would have 4 pounds of each. Okay, so you don't have to do any math to find this. You just have to graph it and then look in the shaded area. And you have to look in the positive area. Like over here, I cannot buy, like here's a point. Am I not writing? Oh, there it is. Is it writing? Okay, that point would be 2, -6. I can't buy -6 pounds of flour, all right? That's why you want to look in the area that's right here to the right of the X and Y axes, the part that goes through right here. All right, because you don't want anything to be negative. Let's take a look at another one. It says a seafood restaurant owner orders perch and salmon. Perch is $4 a pound and salmon is $3 a pound. He wants to buy at least 50 pounds of fish, but cannot spend more than $240. All right, so let's take a look at, I'm clearing off Desmos here. Let's take a look at what we're going to do here. So I know I'm going to have X and Y, and I'm just going to make X perch and Y salmon. It says the perch is $4 a pound, so that would be 4x, and the salmon is $3 a pound, which would be 3x. So I'm going to use 4x plus 3x because I'm buying both of them. And I'm talking about the cost, so I cannot spend more than $240, but I could spend less. I could spend $239, $200, $150. So I have to be less than or equal to $240. It says I can't spend more than $240, but I could spend exactly $240. There's my cost inequality. Now for the amount inequality, I know that perch plus salmon has to be at least 50 pounds. So I want 50 or more, greater than or equal to 50, okay? So I'm going to come back over to Desmos and I'm going to type my equations, or my inequalities. I keep saying equations, I mean inequalities. 4x plus 3y is less than or equal to 240. Nope, that doesn't say 240. That says 240, and I'm going to have to, there we go, okay? And then, and you see, we don't even have to be in y equals mx plus b form. You can do it right here in standard form. X plus y is greater than or equal to 50. There's my second one. There we go. All right, and so what we're going to do is we're going to look in the shaded area. We're going to stay here in the positive x and positive y. So anything in here would be an acceptable amount of fish that we could buy. So let's see, if that's going by 50s, the axes must be going by 10s. This would be 10, 20, 30, 40, 50, 10, 20, 30, 40, 50. So for example, let's say this point right here would be 20, 40. All right, this point right here would be 80, 40. All right, since both lines are solid, we could even pick this point right here, 50, 0. I could get 50 of one and none of the other. Same thing here, 0, 50. Okay, I could be, remember, I can be on the line as long as it's solid. So any of those choices would work. And what we would do is we would say, let's say I'm going to go with 0, 50. So I'm going to buy 0 perch and 50 pounds of salmon. Or let's go with 80, 40. I'm going to buy 80 pounds of perch and 40 pounds of salmon. All right. If I were to actually calculate the cost of these two things, I would find that I would indeed be spending less than $240. And if I add up my pounds, I am at 50 or higher. Okay. So that's how you do these. All right. You read, you come up with your two inequalities, then you graph them and you find 2 points that are in the overlapped shaded areas. All right. What I want you guys to do is to finish the rest of this particular paper. Let's see if I can make this go away. There we go. I want you to go ahead and finish. We've got 3, 4, 5, 6, and then on the next page we have the answer keys. All right. They had to do the graph, but you don't have to do that because you've got Desmos. All right. Please feel free to email me. Let me know if you have any questions about any of this. It's pretty easy to do. The hardest part, I would say, is this part, reading the problem and trying to figure out what the inequalities are supposed to be. But if you really stop and think about it for a second, it's not that difficult to do. All right. So pop me an email if you have any questions. Bye, guys.